Yeah, so we saw our sponsors here. Getting started on HoloLens, as I said earlier, my name is Matt Wilhelm. I work for Inferno Red. I focus primarily on Xamarin development, mobile development, typically UX, you know, iOS, Android, a lot of ASP.NET in the past, WPF. Who's actually built WPF applications, UWP applications, Visual Studio, that sort of thing? Very few people. Okay, great. Well, you're going to learn something new today. I don't work for Microsoft. Obligatory. Since the HoloLens is very new and we're in a building, it's important to say that anything that is speculative is just my opinion and doesn't actually represent them. And of course, objects in the mirror may appear closer than they really are. Okay, so what I'm going to cover, I'll cover setting up your dev environment. Should have hit that pretty well already, so I'm just going to touch on that. I'm going to go over the application programming model a little bit, talk a little bit more about considerations when using the gaze, gesture, and voice as input. And then I'm going to kind of jump right into code. I'm going to show you a UWP application that we at Inferno Red built for a couple of talks and a couple of demos, and that it just runs. And then I'm going to make a couple of modifications to it to show how you can give a little bit better of a user experience on the HoloLens and make some modifications there. And then I'm going to jump into Unity, and I'm going to show you how you can combine a 2D application with a 3D view and take your 2D XAML application and add a new view for the HoloLens that only runs on HoloLens and kind of lights up that feature, right? So with that, just going to jump right in. So to get the tools, we already heard about this a little bit. The main point is that until recently there was a HoloLens technical preview beta version of Unity that was specific, but with the 5.5 beta they've actually started shipping the HoloLens components as part of that. So it will be included in the 5.5 release version. Will include all the player for the HoloLens and everything that you're going to need, so you won't have to have two versions, which is going to save about 15 gigabytes on your hard drive. So a fairly powerful computer is definitely recommended. So let's dive a little bit more deeply into the actual hardware of the device. And that image you got right there is from a very early press picture from Microsoft. So it's an Atom-based processor, 2 gigs of RAM, 64 gig hard drive, Windows 10, 32-bit. The lenses are actually waveguides, which if you go online, there's plenty of research from various companies and academic institutions about this technology. The HoloLens is not the only, it's the only consumer device or semi-consumer device that I'm aware of that's actually using it, but that technology is under development and seems to work pretty well. So there are 4 environmental cameras and 4 microphones, which is what allows the holographic processing unit to chomp through that 1 terabyte a second of data. I think you said that, and that's really what allows that to capture that spatial interaction. You've got a depth camera in there, ambient light sensor, and an accelerometer. So, other than the fact that you've got multiple cameras and the lenses here, it's actually pretty similar to a fairly powerful smartphone, right, or a tablet device. And I think what you'll see here as we go through the rest of this presentation, there are a lot of similarities with developing for mobile phones or tablets that you're going to see with the HoloLens as well. And it's mostly related to performance, right? All right, so the input and interaction. As we talked about earlier, there's the gaze, the gesture, and the voice input. The gaze is a floating point in space, and the gesture is, there's 2 primary gestures. There's a bloom, which I think you probably saw when I was setting up, and then there's a tap, which is like this. And those are really the only 2 main gestures that you have, but actually end up being creating a rather rich experience when you combine those with motion. So for like scrolling and sliding and those sorts of things, and you can grab. So when you're building your apps, you want to kind of think about how a user is going to interact with them and how you would want to interact with them. And the number one thing that I can recommend is try to minimize typing, because typing on the device is just, it's kind of brutal. There's a pop-up keyboard that pops pops up, and you use the gaze and the tap in order to actually click on it. Now, for development purposes, I believe the application that is in the store can run on your smartphone, and you can use your phone almost as a Wi-Fi keyboard, so you can kind of make typing a little bit better of an experience that way. But you probably don't want to assume that your users are going to do that or are going to have the technical ability to set that up, right? So the last one is the voice input, which hey Cortana. And it works very well in a room like this or in a living room, but it tends to have trouble picking up and distinguishing individual voices in a very noisy environment. So like for your commercial applications, like a warehouse where there might be a lot of machinery noise, or like a large crowded room where there's a lot of people, it's going to have a hard time distinguishing. So you typically you're not going to want to rely on the voice input as the primary mode or the only mode of input for your application. You're going to want to leave some sort of indicators in the user interface and then augment that with voice to make it a little bit easier for your users. And you'll see that in a couple of demos where, like in the actual shell, there's any buttons that you can click on. If you hover over it for a second, it'll pop up the name of that, and there's a little microphone next to it, and that just says that you can say that command, and then it'll execute that action, which is a really good pattern to follow, I think. All right, so we saw a little bit about the spatial mapping and the meshes. So what is this? This is the HoloLens creating a triangle-based mesh of the environment, right? And caching and processing those can be pretty expensive. So as you saw in Shahed's demo, the mesh was actually shown throughout the application. Typically, you wouldn't show that in an app that you're building to publish into the store. But what you saw there was that it's continuously processing and reprocessing that mesh as you're looking at things and as objects move around in space. So, like I said, that can take a considerable amount of resources. So, when you're designing, you're typically going to want to focus on making sure that the mesh directly in front of people is very sharp, and that is up to spec, so that way the holograms don't move around too much, and then things like the principles of occlusion will hide holograms behind objects that it's registered, so it gives more of a sense of realism, or allowing your physics objects to work right, particularly when you're bouncing things off of one another and that sort of thing, right? So saw that one. So all of the meshes are based on a coordinate system, and when the HoloLens develops a view of the room, then it's providing a world coordinate set. But as you saw, with the mesh is always constantly changing, those coordinates are not actually fixed. So they're somewhat fluid, and sometimes depending on where an object is placed in the world and whether or not that world changes, you'll see the objects jump around and jitter just a little bit sometimes. So there's this concept of a spatial anchor, which essentially allows you to place an object in a point that is explicitly in physical space, and it won't move. And that object will have its own coordinate system, and then you can use that coordinate system as a frame of reference for other objects. So if you have one thing that doesn't need to move in space, you can set that, and then you can place other objects in that coordinate system, so that as you move around, even if the room changes or people move desks or chairs around, that object won't actually move according to the world as a whole, or the actual room. So that can actually be really useful for helping kind of give the sense of realism and experience. And so you'll see a lot of I've got a lot of links here at the bottom of some of these slides. These are links to the Microsoft resources, so if you go grab the slides that are in the GitHub repo that I'll share, then you can go and kind of read through this. The documentation is actually very, very good. All right, so we talked a little bit about the holographic view, that you essentially have one three-dimensional application or one three-dimensional view running at a time, and then there's the shell, which is essentially analogous to Windows desktop, right? So you see that you saw the holograms that are floating around the room, and then you can have different apps pinned to the walls, and then once you enter into an experience, that takes over the entire device. So you're responsible for all input. You're responsible for being able to get out of it. Obviously, your users will be able to use the bloom gesture to always get back to the start menu. That's built into the operating system, but you're going to have to handle any type of input or interaction yourself. There's really nothing provided by the operating system other than the APIs. So under the hood, and Unity is using this too. These are some additions to DirectX. These are the namespaces that if you go look at, you can see exactly how this is constructed, but you're using holographic space, a holographic frame, and a holographic camera. So you essentially have a world, you have a view into that world, and you have the framing for that. So I'd encourage you to maybe take a look at that if you're serious about development and just kind of get a basic understanding of how this works under the hood. It can actually go kind of a long way. So, okay, so two-dimensional applications are just regular UWP applications, so no actual modifications necessary in order to make them run. And I'm going to show you that here in a few minutes. But the development is very similar to developing for an Xbox. So you have what people like to refer to as the 10-foot experience, right? So you've got this resolution here, 1280 by 720 with 853 effective pixels, essentially. So you have the information density of a tablet, and I'll show that off once I get the device running and we go into the demo app. But you essentially don't have a ton of space, so you're going to want to make sure that things are very touch-friendly, big buttons work really well, and I'm going to show you an example of that. So another thing that you should check out too is this Know the Limitations right here. This link shows you, will tell you exactly which APIs work and which APIs don't work. Currently on the HoloLens, and the best example I can give you is push notifications. So there's no actual user interface for push notifications. The APIs are still there. You can still use audio cues for notifications, but if you send a push notification to the HoloLens, it's not actually going to show up anywhere, right? So, and there's some other things like that that are certainly worth knowing about, but I would check there before you bang your head against the wall trying to figure out why something's not working. All right, so I'm going to show some code because that's, we're all developers and that's kind of what we want, right? So this demo that I'm going to do here is it connects to the Marvel API, and it's just a basic comic book app. So there's a series of superheroes that you can select, and when you select a superhero, it's going to show a list of their comics. So we are making a web call, and I'm running through my tablet, so hopefully that works out well for me. We'll see, but basically what I'm going to do here is I'm going to walk you through the XAML view to show you that it's just a standard app. I'm going to run it, and then we're going to make a couple of modifications and make it look a little bit better. So let's go ahead and get over to code. All right, so this is a pretty standard application. We've got a core library, a couple of data services, view models, following MVVM pattern. We've got a main shell view model here, which is just a collection of characters, and then those characters are the navigation items. I got Iron Man, Captain America, Thor, and a couple of icons there to just to make our UI look a little better, right? So then the actual main view is actually going to connect and get your actual comics here, and the view itself, this one. All right, so the view itself is just a series of images that are going to show up vertically, and this is just your regular desktop app. So while I'm talking through this, I'm going to hit play here so this actually runs. All right, so this is the emulator that Shahad was talking about earlier. I find that it's actually pretty useful for doing small deployments if you're working on one particular thing, because the deployment to the actual device, the cycle from pressing play in Visual Studio to actually getting it to show up on the HoloLens, depending on your computer and your network, can be upwards of a couple of minutes. So this is typically how you'll build a feature, and then you'll move over and start testing on the actual hardware. So I believe it's place in space. So you'll see if I use my left mouse button, the gaze tracking, if you can see that right there, right in the center, that's moving with my mouse, right? So I've got this menu over here, So I'm going to open that up, and then now I can select Iron Man, and if the demo gods like me, we're going to see some comic books here. Great. Okay. So we got some comic books, but as you can see, like this isn't a very great user experience for this device. You know, that menu was pretty hard to hit. Even here using a mouse, I was having a hard time trying to get to this menu. So what I'm going to do, I'm going to stop this, and I'm going to bring up a couple of other views that I've pre-built. So for a previous talk that Inferno Red did, we actually built this view that is essentially the same view for the comic books, except that it's built for the Xbox. And this one that's built for the Xbox has some differences in the margins, and particularly we have a horizontal grid view. So rather than seeing everything show up in a vertical list, we're going to see one list that just runs horizontal, and it's only going to have one item in it, which I think is going to feel a little better, right? So the way that this is done, UWP and the new Visual Studio are actually smart enough to figure out if you use same naming conventions and put things into these specific folders here. So under views, I've got one for the device family for the Xbox, and then I've created one for the holographic. So I'm going to go ahead and add these couple of existing items that are just sitting out there. All right. So I also changed the shell, you know, because that split view that we had where the menu pops out to the side was not very easy to look at. So what I ended up doing is I just created this, I used a grid view instead, and I made the icons much, much bigger, so they're going to be much easier to click. So we've got a regular grid view, same on selection changed event, same nav item, same view model. It's using the exact same code behind file. So if I go right here, this main shell, it's actually still using this. You can see there's nothing in this this file that I added. So the operating system will figure that out at runtime and know exactly which one it should use. So let's go ahead and hit play now on this one and see what we get. All right, well, that's a little better. I think I can click on that. I don't have to go hunting. So let's see here. All right, there we go. See, so now we've got this much larger horizontal view here that's going to be a lot easier to interact with. And I'll show this off a little bit more outside the emulator, because as you can see, like I'm trying to scroll this thing right now, but it doesn't work so great in the emulator. Great, so does anybody have any questions about that so far? Okay, so you can, if you look here, I actually wired up the very top bar right here. The operating system gives you this interaction for your shell here, and this will allow you to position your two-dimensional application on a wall or to move it around, and part of that is your standard back button, right? So I think it's in the app.xaml.cs, we wired up our back state. There we go. Yeah, so on back requested, root frame, go back, same navigation patterns that we use for WPF application, UWP application. That all still works, and it just kind of works right out of the box, which I thought was kind of cool. Okay. All right, so that's cool and all, but it's still, you know, just a two-dimensional application. There's not really a lot of excitement there. There's not really a lot to show off. So what we're going to want to do is add a three-dimensional view to our application that's only going to work on the HoloLens, right? So I want to just quick primer on Unity for those who haven't used it. Everything is it's still object-oriented, so there's this concept of a game object, right? And the game, like, you can use a game object and you can attach behaviors to it, and it's going to have a startup loop and a shutdown loop that runs, and then there's going to be an update loop that runs every frame, right? So actually, I think I have a great example of that right here. So here's a very basic script. This is what it's just going to give you right out of the box. Let me zoom in on that. So you've got your start and your update. And this, the start will initialize once, so you can initialize variables. You can create your objects or your space, or grab things from the dependency container, those sorts of things that you're going to use inside the script. And then the update loop will run every frame. So you can use that to manage your control flow and say, all right, this frame has a specific amount of time passed. No, it hasn't. Okay, skip it. Okay, and then once a certain amount of time has passed through, say like 30 seconds, you can let that fall through, and then whatever script you end up putting in here, whatever behaviors you want to define, you can make sure that those get executed. And you can do things like move objects in position and space. You can create new objects. You can destroy objects. You can let objects interact with other objects that are in your game. And this isn't limited to games, by the way, too. Everybody always talks about using Unity for games, but this would be very applicable to building a charting application for real estate or a bank or something like that. Or in fact, I think I saw somebody has been working on an application for air traffic controllers, which I thought was really cool. So you can actually visualize on a table the flight patterns that are coming into your airport. I thought that was really neat, but it's not just for gaming. There's a lot of commercial applications that you can build with this as well. So let's go over to Unity itself. So Unity follows this fairly standardized folder pattern where everything is underneath the assets, and you can have different models, prefabs, scenes, scripts. These are, I just made these folders. These are folders that you'll typically see in just about every project. People follow these conventions. If you create a new script, it can get dropped into the scripts folder. But what I did here is I got online and I found a series of 3D models for Captain America and Iron Man and Thor. So if you can see down here in the corner, I got Iron Man right there. And I brought those models in. I brought them into my application, but as you can see, rendering. He's very, very big. So if I try to make him a little smaller in real world coordinates, so you can see how we've got just a foot here. So what you do is you can bring your models in, you can adjust them, you can attach scripts to them, you can provide animations, meshes, color changes, whatever you want, and then you can essentially drag that down into your prefab folder and create it as a prefabricated component, and then all of those modifications that you've made up here get attached to that component, and then the component itself ends up looking much more, that ends up becoming reusable, right? So I'm actually going to remove that here. So I've got this character object that I created, and I attached a script to it, which I'll show off here in a minute, and then I have I have these prefabs that are attached to it. So how did I do that? So this is the project that gets generated out of Unity. So when you go in, you go to File, Build Settings. You saw this briefly in a slide before. Select your Windows Store, Universal 10, any device. Instead of picking the Direct 3D output type, which essentially gives you a series of DLLs and then a console application that runs, I selected XAML. And what that does is it instead outputs another project here that is an actual XAML application that executes that attaches the three-dimensional view to a specific page. So this is really what Unity is working with here. So it's got a page, and it's got the swap chain panel, and as you can see, it's using DirectX under the hood. And then I'm going to dive into a little bit more depth on that here in a few minutes. But then the actual scripts get outputted into their own project as well. And what I did is I brought in the demo application that you saw in my other instance of Visual Studio here that we saw run. That is the same application that's here. And I don't think you would ever do this in production, but what I ended up doing was actually file linking each one of the files from the actual demo project into the Unity-generated XAML application. So those views are here. You can see my device family holographic, and it's actually a linked file, right? So, all right, I think it's time to see this thing run. And this is the web portal that you saw a little bit earlier. I'm going to do the same thing where I'm going to run this on low. I'm also going to record this so that it looks good. And let's get the live preview going. And of course, I'm not on Wi-Fi. Always the Wi-Fi problems. So I just typed in a Wi-Fi key, so you can see all that clicking and head moving around. Not particularly fun. All right, preview's back. Yeah, Lee, this is not going to let me record this, but that's okay. Okay, all right, so the two applications that I ran earlier, have already preloaded them on the device. I did not want to do any live debugging simply because the deployment process is very long. So as you can see, I've set up a few things in the room here. Let's read my gestures. So this one right here, this Marvel demo application, that's the first one that we did that was not with Unity, right? So this is the final state that you saw that I ran through the emulator. I've got my big buttons. You've got your control bar here on top. Now, what's interesting is, okay, so you just, if I'm just hover on that adjust right there, you can see how it pops up and says the word, which I'm not going to say because it's going to do it. And then if I resize this window, you can see that the window resizes, but the content doesn't actually move. It ends up stretching. And that's just kind of showing that you're still limited to the pixel density that was shown off before on that earlier slide. So there's no scaling, or there's no responsive design that's going to happen. You're not going to be able to have one row of items and then make it longer and see another row of items in your applications. The web browser does do that, and you have some control with scrolling, but that's essentially the behavior that you're going to get. So I'm going to hit done here, and I'm going to click on, let's click on Thor, and hopefully this will work. There we go. All right, so much bigger, pretty good view of our application. I can pick that up, or I can shrink it back down. I can grab it, I can move it over here, and that looks pretty good. It's pretty easy to interact with. You don't have to focus very, very closely on really small UI items, so that seems to work pretty well. So, all right, so let's go look at the 3D one that we built. So I'm going to click on Iron Man. Come on, web calls. So now what I've done is in the click event, I have attached the three-dimensional view to this application. So when I click on one of these comics, it's going to spawn the Unity view, and it's going to populate it with the character that is selected. So I'm going to click on that, and you'll see that we have I haven't done any optimization to this, so it's instantiating the entire swap chain through Unity itself, so Unity is going to spin up. Obviously, when you're building an application, you're not going to want to do that, but then you can see that I get Iron Man. And he just shows up right in front of me. So what happened there? You saw that he spawned right in front of where I'm standing, right? So I have not done, this is like the bare minimum, easiest thing that you could possibly do. I'm just dropping a 3D object directly into space and told it to put it directly in front of the camera, right? So he showed up right where I was standing, and as I back up, he is maybe a little bit larger than life, right? So you can also see that if I get really close, all of a sudden things are going to start disappearing. Now, Microsoft recommends that you set your clipping plane to 0.85, which is probably a little bit longer than what you would do in a regular three-dimensional game, but this is essentially the effect for, if you have any Nintendo 64 GoldenEye fans out there, you remember you can jump through walls, and there's certain little spots where you can clip through the level and go down to the next level. That's essentially the same effect that's happening here, and it's mostly to save rendering processing power, but also to show that the fidelity of the model just can't really be rendered when it's very, very close, right?
I would have two notes there.
Sure.
So, he mentioned a recommendation for the clipping plane numbers in case you don't remember what they are. When you go through Holographic Academy tutorial, you can actually, when you go through the step-by-step line, they have the recommended numbers there. So even if you forget, just go through the tutorial and they'll be there. And once you use them a couple of times, you'll know what they are. And also there's something called Holo Toolkit, which is open source in GitHub. You can actually use the Holo Toolkit to make your life a little easier. It does a lot of stuff for you. And he mentioned over here that you can look through stuff. I've seen in real-life applications, customers who purchase the HoloLens or who tried it for the first time, they download a Unity and a Visual Studio to build stuff. They're just looking at a 3D object and a 2D screen. And when they put on the HoloLens, now they're actually looking inside their not only stationary but animated 3D object. They're like, wow, I built this stuff here. I didn't even know what it looked like from the inside, and now I'm thinking in my head they're seeing something. So that's something like a wow factor. So be prepared for that as you work with clients in the future. Yeah, go ahead.
Right. Yeah, and the point about the Holo Toolkit actually is definitely well-founded. So there's this open source project that has a lot of helper scripts and tools for Unity that can help you get started. When you're setting up one of these projects, the first thing that you have to do is you change the default camera. You make it so that the actual background of the camera is black, and that ends up rendering as transparent on the HoloLens. And then the default camera actually is zeroed at the X and Y, but it's 10 units out on the Z coordinate. So for kind of like a 2.5D side scroller sort of thing is how it's originally designed. But since we are the camera and we're moving in space, we want to make sure that everything is set to the 0 axis inside of the application. And you can, that actually, there's tools inside of the Holo Toolkit where you can just drag and drop those directly into your project. There's other projects for helping, or other items for helping with spatial mapping and those sorts of things. And I'll show a link to that, but I highly recommend going and checking it out. It's also a really good example of, to see how these tools are built, and then you can understand exactly the type of things that you're going to have to do in your application, and just good code examples. All right, so let's stop live preview. Take that off for a second, and let's see how we did that. I know we're running a little bit over, so I'm going to try to be a little bit quicker. But I do want to kind of drive this one point home here, which is how I was able to combine the 2D and the 3D experience. So as I said, in our main view, we've got this on item selected event, right? So if I could click into that, I put a check in here for this device family. Are you guys able to see that? Is it big enough? So I put this check in here for this device family to say that if it's not holographic, just return. So don't execute this code. And what this code is going to do is it's going to grab the data context of the character from our view model. We're going to assign him to an enumeration value that is from inside of Unity in that pick character class, which I think I showed that, right? So this is when the character shows, this is the script that actually runs, and this is my mono behavior. I have a superhero object, which you can almost think of game object as an object primitive. It's basically the same thing. And then I have the prefab for Iron Man, Captain America, and Thor. And back in Unity, you can see I have these links right here for Iron Man, Captain America, and Thor. And what I did was I just took that prefab and drug it right over here and drop it on that box. And then the way that Unity works with these public fields here, it's going to end up assigning those at runtime. And then in my start loop, I'm saying should update scene equals true. So I'm going to let that update fall through the first run for the control flow. And what I'm going to do is I'm going to say, hey, if there's a superhero who already exists, let's destroy him. And then depending on which one is selected, let's show that particular prefab and then instantiate that object. So that's like the very basics of a flow that you would follow for just about any sort of application or any sort of scene or object in Unity, right? So I made this static void method here called setSelectedCharacter that takes that enum, and that allows me to change the character and then set the should update to true. And the next time the loop runs, it's going to let that fall through, right? So back in my XAML CS, I'm setting that same enum value, and then I'm going to use the application view switcher APIs in order to instantiate a second window and bind that window to the Unity page, the DirectX swap chain that we saw earlier. That's right here, right? So these are the same APIs that you would use for creating a second window of your application for any UWP app. So take the mail app, for instance. If you want to, pop out your mail message and show and let people slide that over and put it in another window, you would use these same APIs in order to do that. So it's all very standard. Not a lot's changed. So I'm going to use the view switcher to try standalone. We're going to create a handle to it, and then we're going to tell our main window to activate that view, right? And that's essentially the magic that happens there. The frame, you'll see here in the frame navigate event, I'm passing the enum model into this Unity main page. And if I jump in here into the code behind, we can see a little bit of how Unity actually works under the hood in a XAML application. So this class was generated from Unity when I hit export button. This is essentially what it gave me. And I've made a couple of small changes, but most of it is there. So you can see they've got some event handlers, their splash screen. They have their own particular callback methods in order to get data in and out. They've got a check for initialization, rendering, window events, swap chain. And these are all terms from the DirectX world that you'll see. So what we're curious about here is the onNavigated2 event. I'm taking the character out of that navigation event, and then I'm using that static method to set that selected character right there. And I just know that there's only one instance of this, so that's why this works. There's probably a better way to do it. Unity has a dependency injection container, so you can bind things to that and then get your data back and forth, but I just wanted to show that this is one way where you can get data in and out. Cool, so that is most of it. Oh yeah, absolutely. So this is, like I said, this is the most basic demo that you could possibly do. What I typically do, I'll have I'll have a main script that's going to run, and that's actually going to manage the initialization of the game state, right? So it's not uncommon to have one object and then a series of prefabs that are connected to it, and then do your instantiation inside of that script. So in this pick character, for example, I could instantiate just Thor. Yeah, so I can say, all right, show me the character that is selected and Thor, like if they wanted to do battle, for example. Now, in this instance, they're going to show up exactly in the same spot, so you're going to want to do some camera transforms in order to position them with respect either to the camera, or you can use the spatial space APIs, or you can even use spatial anchors, those sorts of things. So I actually had somebody ask me the other day, how does that work? So here is what you would use in Unity to actually set up the surfaces. So the main point is that you get a hook into the HoloLens APIs to start observing for the surface changes, and then there's an update change event that'll fire, and essentially what you're going to get back is on surface changed, and then you can go ahead and iterate through that, make any changes. Transform is generally the term that they use for movement, so place it with respect to something else. You can add components. You can attach something to a world anchor, and then you can tell it to switch over into that that anchor's coordinates, and then put something in relation to that position in space. But all this is directly from the developer portal on Microsoft. So if you go check this out, the documentation is really good. It's pretty dense, but it's actually pretty helpful. So yeah. Does anybody else have any other questions? I know we're running a little late, but no one? You all got it? We're all professionals now? So who's going to go home and play with us today? Yeah.
Who went to free HoloLens today? So yeah, if you guys want to try it out, I'll be here all day.
Yeah, and I'll be over at the in front of Red booth, so I actually kind of anticipated people were going to want to see it, so I set up a small demo. I can probably do a few minutes with just about everybody. I am going to eat. But yeah, so I have not tried to use it outdoors. When I talked to the people who know a lot more about this than I do, they were like, "Don't use it outdoors." One of the main reasons actually is that the solar radiation kind of messes with the sensors a little bit, so it's really hard to get like really solid tracking outside because the sun is just so powerful that, I mean, unfortunately human beings have not figured out how to look directly at it yet. At least cheaply. Go ahead. No, go ahead.
Also, you may have figured out, in order to see your real world around you, the holograms you see are not entirely opaque, right? That's by design. So HoloLens doesn't take light away from you. That's why it can't represent like a pure black color with 000 RGB.
Right.
The purest of colors would be a little more transparent, right? You see some level of transparency, which is again by design. Imagine if you had like all colors represented, you wouldn't be able to see anything, right? So a little bit of transparency involved, and because of that, if you can imagine if you're outdoors and it's really bright sunlight, everything will be much down.
Yeah, it gets very washed.
But if you understand how it's developed and what it's used for, then you get a better sense of what you can.
Yeah, and you can even see that inside too, in like a very large room. If it hasn't had an opportunity to map everything, it'll map a corner, and then you can world lock things just in that corner, and those will look pretty good. They won't move around, but the farther that you get out, and the farther that you look down, like kind of off into a horizon, the actual positioning accuracy ends up getting worse and worse and worse. And I mean, that's just. It's a dev kit, and I'm sure they're going to iterate over the hardware several times moving forward. Other companies, like there's partnerships with other companies are able to build hardware too. So this is like just one reference device, but it does have some limitations, and it's typically indoors mostly. Anybody else? Cool. Well, thanks for coming and listening to me yammer on about this. It was enjoyable. Thank you.